Finding the probabilities using the standard normal distribution by Morgan Miller. So this sign here is pointing to the left is known as a less than sign. The one pointing to the right is known as the greater than sign. And Z is the variable that denotes the probability of a standard normal variable. For example, we have the symbol to denote the standard normal distribution, and we have the less than sign and the greater than sign. These numbers are also your z-scores. When finding the areas for each z-score, we need to look in the back of the book to the Appendix A, Table E. Table E is the standard normal distribution table. When finding this, we need to notice that when you're going down the table, it's a whole number plus the 10th place. And when you're going across the top, you're only finding the 100th place. So then you put them together and you'll get like a 1.48 is basically what I'm trying to say. For example, we see that the horizontal line is the 100th place and that the vertical line is a whole number and the 10th place. You can also see that it is used without negatives as well. So let's use, for example, 1.34. So basically we need to go to 1.3, then we go to the 100th place, 4, your mean is 0.9099. That's your probability. So let's try one. If we go to the back of the book and look at 1.27, we go down 1.2, go over to 0.07, and we should get 0.8980. So let's actually try to find the probability of the standard normal distribution. In this notation, this says to find the probability of with the standard normal distribution less than 1.91. So when doing this, we need to go to the back of our book, go to 1.91, so we go down 1.9, go over 0.01, and we should get 0.9719. But therefore, we're trying to find the probability of the standard normal distribution. So we need to move the decimal place over twice to make it a percentage. Therefore, we get 97.19%. Let's do another one. With this, we see the probability of normal standard distribution greater than 0.59. Now let's not get tricked by this one. Every time it goes to the right, we always need to subtract 1 minus the probability that we get, because we're doing the opposite of what we did before, because it's greater than, not less than, if that makes sense. So by doing this, we need to go down our chart in Table E. We need to find 0.5, go down, we need to go over 0.09, and we should get 0.7224. But don't forget, we need to minus 1 minus 0.7224, and we should get 0.2776. And that is the probability of what we need to find. So we need to find the probability, which is a percentage. So we need to move our decimal place over twice to get 27.76%. Okay, last example, we need to find the probability of finding a z-score between 0.25 and 1.74. Between those numbers. Just making that clear. So, to do this, we need to find this variable, probability of this with the probability of this z-score, and we need to subtract the both to get the probability for in between. So let's do 1.74 first because that's the biggest number. Therefore, we want to subtract the bigger number with the smallest number. So with 1.74, we go down the z-scores, 1.7 over to 0.04, and we get 0.9591. So we just need to keep that off to the side, and now let's do 0.25. Go down the z-scores over to 0.05, and we get 0.5987. So now that we have our two numbers, we need to subtract the two from each other. We need to subtract 0.9591 minus 0.5987. We get 0.3604. But with this, we need to find the probability. Therefore, it needs to be percent. So we move the decimal place over twice, and we get 36.04% as our probability of finding a z-score in between these two numbers. Thanks!